Network analysis. Network analysis purposes to visualize the pattern of relationship that connect entities. In this movie, we can consider the characters as the entities. And as you might have seen before, in a network, there are dots, and the dots are connected. So the entities are eventually resulted as dots in visualization. So the characters are visualized within these dots, and based on our observation, who were appearing together, we can count the relationship between M1 and M2 and F1 like that. So in chapter 1, we can count 10 different kinds of relationship, and across the chapters, maybe we can accumulate the frequency between M1 and M2 as number 10 in the end. So we know that the entities are here at least M1, M2, and F1, F2, F3, but based on the cumulative frequency, we can decide which connection can be thicker than the other one. So actually that's all. But by doing so, instead of looking into this table with a lot of numbers and a lot of combinations, we can figure out the relationship of the entire characters at a glance. That's the benefit of the network analysis. It gives us very intuitive big picture over the data set. Okay, so let me introduce to you the terms which are frequently used in network analysis. Firstly, the nodes. So these circles, they are dots, right? But in network analysis, they are either called as nodes or vertex, or in plural form, vertices. And their linkage between these entities or vertices are called as link or edge. And this linkage can be simply a link, but it can have a direction, like something flows to one direction or both directions. Then you use the arrows for that. And also like this one, the thickness can be different depending on how you have weighted the relationship. So in the background, it's illustrating the IoT home environment, and maybe the data are transferred to different devices, and we can visualize this data transfer using this network analysis. And here are another example, some more examples about network visualization, and they look very similar but slightly different. So first one has the vertex and edge, but there are no direction, right? So the countries are the vertices and they are linked through the edges. And so maybe the edge can be like mutual trade, consensus, or FDA agreement, like that. And the second one is the name of the cities. And it looks like some flow are there, like some flu or some traffic or some logistics are flowing following these cities. So this network can illustrate this, and it has a direction. And third one looks like an SNS, like someone follows the other one and they are following each other, etc. And the first three visualized networks have one mode, which means they have one group of entity. But the last one has two groups of entities, so it has two modes. First mode consists of people, James, Brian, etc. And the second mode consists of books. So who borrowed that book, and then and so on. Right. So once we have a visualized network, especially when you are going to compare one network with another network, then you cannot simply say, look, they look different. So you need to quantify their characteristics. And there are many terms or many parameters you can use for this purpose. And they can be categorized into four groups. The first one is the structure. So it's the shape of a network, including the link and density, average degree, and main distance and diameter. And the table here is summarizing the physical or the quantified characteristics of this network and derived from a GAFI open source based tool which is dedicated to the network visualization. And I think it's mainly about structural characteristics like average path length and diameter and the overall graph density and average weighted degree, so how it is structured. And the second characteristics are about the centrality. Some network has very scattered tendency, but some networks have very strong like central point, like this one, user and mobile, something like that. And the third one is cohesion. Like this one, we have a user-centered group and a mobile-centered group. So whether there are some like groups within one network. And last one is to find the role of applying particular nodes, which is connecting many different nodes, or which is like has special characteristics. So it's called coordinator or representative or gatekeeper or itinerant blocker or liaison, etc. So there are really a huge number of different characteristics, and you can it depends on your research purpose. You can focus on what parameter you need to address in your research. But in general, these features are the most frequently used, the structural characteristics about the network. And using GAFI, you can draw out of the same data, you can draw different graphics, and you can choose whatever you want. So based on the layout algorithm, the drawings are appearing completely different. So if your research is needing network visualization, I highly recommend you to use the GAFI because using Python or R, still the network visualization is still quite limited. But if you need more than GAFI function, then maybe the JavaScript is a good option. Let me introduce you one of the research my lab has recently conveyed. We have collected the chair image data set from MoMA website, and some chairs consist of a single material, but like this chair, some chairs consist of more than one material, so it has material combination, and we try to identify what material combinations are frequently found in these masterpiece chairs. This chair, the distributed chair, consists of wood and white plastic, for example. Right. So if you copy this data and if you use R, then you can simply paste here and then okay. So the chair data were retrieved, and these chair data are actually here, the identical data, and it's real-time updated, so the same data. And let's go back to here. It's simple. So you create a net, and then you declare the degree as the impact, and then the vertex size, so the node size is in proportion to the impact. Okay, so as you see here, the impacts are the numbers. Okay, then we draw the plot. Yep. Okay, so black color is centered and it has the highest frequency, and black and chrome are combined most frequently together, or black and white are combined frequently together. And you can find out like this one, betweenness can be identified just by placing this function, and the black color has the highest betweenness, followed by yellowness, and then gray, and so on. So using R, you can easily perform the network visualization. Okay, for beautifying your network analysis, you can refer or you can consult different websites. And this is actually the final form of the tier one. So I have visualized after having more tier data set and visualize here not only color combination but also materials. So here black leather is distinguished from black plastic. And this one is another very interesting research paper written by Dr. Kim Eun-jin. In this paper, there were 6 modes. So the node groups were 6 kinds of. And she tried to figure out how the designers are developing their design ideas. So based on their education background or attitudes, designers can have a different mental type of developing their ideas. This person is finding an initial idea and developing or elaborating this idea furthermore. But this person is like always having different ideas, and the different idea initiates another different ideas, and and so on. So using this network analysis, she could successfully visualize how the people were thinking. So once you have the data set like this one, it's quite easy and quick to draw the network. The challenge is how to cook your data and process your data to become like these 3 columns. I think this is the creative part, how you can collect the data and restructure data into this kind of form. And once you have a data set like that, then it's easy to draw this network analysis.